Okay, here is some applications for polar coordinates. You'll find that we do convert again between rectangular and polar quite a bit, and a common theme is to put them in what we call trig form. So we have complex numbers in the rectangular form, and those are a plus bi. We graph ab on the imaginary plane, and so we can also do this with the trig form. And in this case, it's r times cosine theta plus I sine theta. Sometimes it's written as r cis, and in some of your engineering and upper math classes, you'll see it written as r and the angle symbol with theta, and this means that we want the complex number in its trig form. So again, you're going to rely on the relationship between rectangular and polar, and instead of xy, notice that things have switched to AB, and again here with inverse tangent. And if I want to convert from the polar back to the complex form in the rectangular, then we use AB. The signs, SIGNS, are very important here. So if I have a complex number, -9 plus 9i, and I want it in its trig form, r theta, then first I have to identify r and theta. So you'll have consistent steps when working through these. Here notice that for r, we took the square root of a squared plus b squared. For the most part, you're going to leave them in their exact form unless it asks for you to give it in a decimal form. When I do the inverse tangent, I have to pay attention to the signs. The fact that y is positive and x is negative tells me that it's in quadrant 2, so that when I do the inverse tangent of -1, and we rewrite it as tangent theta equals -1, we want the theta that's in quadrant 2. And theta is equal to 1 at pi over 4, and it's -1 in quadrants 2 and 4. So in quadrant 2, that would be where theta is 3 pi over 4, and in degrees would be 135. So once we figure out r and theta, then we're just plugging it into the format z equals r times the quantity cosine theta plus I sine theta. So the biggest thing here would be these signs. You really want to pay attention to which quadrant you're sitting in. And here's another one where, again, we're squaring a plus b squared to get the value for r, and we want to do the inverse tangent. You want to clean this up so that you get this nice special angle, and we know that this happens at 60 degrees, where it is the square root of 3 over 1, and I want to recognize that y is negative, that b is negative and a is positive, and I know that that's in quadrant 4. And so when I do the theta value, then we look for that reference angle of 60 degrees. That's going to put us into quadrant 4. So once I get r and I get theta, then I can plug them into this form. And then those are just some more examples. Multiplication and division, you have these formulas here. We can identify z as the first complex number and w as the second complex number. So when we multiply, we're taking z times w. Notice that you're multiplying the r's and you're adding the thetas. When you divide, it's important to recognize which one's on top and which one's on bottom, and then we subtract the thetas to get those values. And so here's a really nice example of z and w multiplying as well as dividing. To do the powers, this takes a little bit of time, so you're just going to have to learn to be patient. It is a longer formula. If I want a complex number to its power, then you're going to take r to that power, and you're going to multiply that power times theta. And it's not just as simple as doing it once. When k identifies the power, so if they want the z cubed, if they want z to the 5th, then that cubed and that 5th are your k's. And so you're going to have multiple answers as you go through, where k is 0 all the way to n minus 1. So here's one where you have z cubed. So you're taking 2 cubed, and then you take that power times the theta. And here you're transforming it from polar back into its rectangular format. So the cosine of 240 degrees, well, that's negative 1/2. When I take that times r, I get negative 4. And then the sine of 240 is negative radical 3 over 2. Again, taking that times 8, and you get the negative 4 radical 3. If you have to go the other way, so now they want you to find the cube root of a negative 4. Rewrite this in its complex form. So that would be z equals negative 4 plus 0 times I. And if I want to find the cube root of that, we identify r and theta. Notice that k is 0 through 2 because you want 0 all the way to n minus 1. And once you find what r and theta are, so when k is 0, what do I get? Well, here was my r value, again, square root of a squared plus b squared, but you want the r to the n, and in this case it was the third power, or the 1/3 power. And so when k is 0, what do you get? And then you're just going to keep walking through. When k is 1, what do you get? And when k is 2, what do you get? So if you have the 5th root of something, then you're looking at 5 answers because you're going to go 0 through 4.